Let's revise the arithmetic progression. So first of all, we should know what is the arithmetic progression. So a sequence of number or a list of numbers where the difference between the successive numbers, or we can say difference between the consecutive numbers, is constant. The terms in an arithmetic progression are usually denoted by A1, A2, A3 and so on, where A1 is the first term, A2 is the second term, A3 is the third term and the last term AN is the nth term. For example, we can take 2, 4, 6, 8, 10, 12, 14 and so on. This forms an AP as we can find out the common difference between the two terms, that is 4 minus 2, it is equal to 2, 6 minus 4 is equal to 2, 8 minus 6 is equal to 2 and similarly for all the terms. So here we are getting the common difference is same for all terms. So 2, 4, 6, 8, 10, 12, 14, this is an AP. So the difference, or we can say the common difference, is denoted by D and it is given by D is equal to A2 minus A1, A3 minus A2, A4 minus A3, like this. When we find out the difference between the next term and the previous term, if it is same, then any sequence of numbers is called an AP. So the common difference D is A2 minus A1, or next term minus previous term also we can say is the common difference. Now there is the formula for nth term of an AP. So this is given by AN, where this AN denotes the nth term and it is equal to A plus n minus 1 into D, where A is the first term, D is the common difference and n is the number for the term, that which term we are finding. If we are finding n is equal to 10, that is A10. Okay. So formula AN is equal to A plus n minus 1 into D is the nth term. Similarly, when we have to find the sum of the numbers given in AP, so what we will do? We will do first term plus second term plus third term plus up to the last term. Okay. So this sum is called the sum of n terms of an AP. Remember, when we are adding the numbers of the sequence is known as sum of terms, and in the terms of in the sense of arithmetic progression we called it sum of n terms of an AP and it is denoted by SN. So the sum of n terms of an AP is given by n upon 2 into 2A plus n minus 1 into D. So after the introduction of this chapter and the formula for nth term and sum of n terms, let us practice some problems based on these two formulas. So first question is, an arithmetic sequence has its fifth term equal to 22 and its 15th term is equal to 62. Find its 100th term. Now in the question it is given A5, that is fifth term, and it is equal to 22, and A15, that is equal to 15th term, is equal to 62, and we have to find out 100th term, that is A100. Now let's solve it. As this is the arithmetic progression, so we can define the first term of AP is A and the common difference is D. Now it is given that fifth term is equal to 22, so we can write A5 is equal to 22. A5, that is fifth term, and A15 is 15th term, is equal to 62. So by using the formula, nth term of an AP is An is equal to A plus n minus 1 into D. We can put the value of n is 5, and next time we will put the value of n is 15. So let's put A5 is equal to A plus 5 minus 1 into D. So 5 minus 1 is 4. So A5 is equal to A plus 4D. Now A5 is given 22, so we can write 22 is equal to A plus 4D. From this, fifth term is equal to 22, we are getting the first equation. Now let's start for A15. So A15 is equal to A plus 15 minus 1 into D. So it is 15 minus 1 is 14. So equal to A plus 14D. As it is given, A15 is equal to 62. So 62 is equal to A plus 14D. Here this is the second equation. Now by observing these first and second equation, we conclude that if we subtract these two equations, we will get the value of any one variable A or D. So we will do the elimination method. So let first and second term are here. So we subtract the first equation from the second. So we get 62 minus 22 is equal to A plus 14D minus, first equation is minus A plus 4D. Now this minus is multiplied the terms inside the bracket. So we get 62 minus 22 is 40. So 40 is equal to A plus 14D minus A, minus and plus becomes minus 4D. Now this minus A and this plus A will cancel out, and we have rest of the terms are 14D minus 4D. Now 14 minus 4 is 10D. So we get 40 is equal to 10D. Now this 10 divides 40. So we get D is equal to 4. Now we can put the value of D in any one of the equation. Either it is in first equation or it is in second equation. So let we put the value in the first equation. 22 is equal to A plus 4D. So 22 is equal to A plus 4 into 4. So 4 into 4 is 16. So we can write 22 minus 16 is equal to A, and by subtracting this we get A is equal to 6. Now we have the first term is 6 and the common difference is 4, and we have to find out the 100th term. So 100th term we can write by nth term formula an is equal to a plus n minus 1 into d. A 100 is equal to a plus 100 minus 1 into d, that is equal to a plus 99d. Okay, then we put the values of a and d here. So we get a 100 is equal to 6 plus 99 into 4, that is 6 plus 396, and 6 plus 396 is 402. So we can write a 100 is equal to 402. So we get the answer. 100th term of the given AP is 402. Now, in this way, we can find the nth term of the AP. Now let's do the second, where we will use the sum of n terms of an AP formula. So second question is, find the sum of all positive integers from 5 to 1555 inclusive that are divisible by 5. Now the meaning of this term inclusive, that is, we have to write the numbers which are divisible by 5 from 5, and the last number is 155 will also count. So let's start the solution. As the first few terms of the sequence of this positive integers from 5 to 1555 which are divisible by 5, we can write 5, 10, 15, 20, 25, 30 up to the 1555. So 1555 is the last term from 5 to 1555, which is divisible by 5. Now in this one sequence, or we can say in this progression, we are getting that a is equal to 5, and the last term, that is an, is equal to 1555, and its common difference is 10 minus 5, 15 minus 10, 20 minus 15, that is 5 for all terms. So D is 5, A is 5, and the last term is 1555. So we use the nth term formula, that is an is equal to a plus n minus 1 into d. We put an is equal to 1555, a is 5, d is 5. So we will get the value of n. That means we will find out how many terms are there from 5 to 1555 which are divisible by 5. So let's put the values. 1555 is equal to a plus n minus 1 into d. Then d and a both are 5. So we put 1555 is equal to 5 plus n minus 1 into 5, and 1555 is equal to this 5 we transpose to the left hand side. So 1555 minus 5 will becomes 1550, and it is equal to 5 into n minus 1. Now this 5 also we can take in the left hand side, so it will become divided by 5. So 1550 divided by 5 is n minus 1. So when we divide this, we get 310. So the 310 is equal to n minus 1. This minus 1 we will transpose to the left hand side, and it will become plus 1. So 310 plus 1 is 311. Now we have, there are 311 positive integers from 5 to 1555 which are divisible by 5, and now we have to find what is the sum of these 311 terms which are divisible by 5. So we can use the formula now, that Sn is equal to n upon 2 into 2a plus n minus 1 into d. We put the value n is 311, a that is equal to 5 and d is also 5 and n is 311. By putting the values we get the sum. So let's put d is 5, a is 5 and n is 311. So S 311 is equal to 311 upon 2 into the multiply by the 2 into 5 plus 311 minus 1 into d is 5. So after solving this, 5 into 2 is 10. So we get 311 upon 2 is 10 plus 311 minus 1 is 310 into 5. Then after 311 upon 2 is 310 multiplied by 5 is 1550, and this 1550 plus 10 will become 1560 multiplied by 311 upon 2. Now this 1560 divided by 2, so we get 780. So sum of 311 terms is equal to 311 into 780. So product of these numbers gives the sum of 311 terms. So S311 is equal to 2,42,580. So we can write the sum of the all positive integers from 5 to 1555 inclusive that are divisible by 5 is 2,42,580.